In the early hours of May 23rd, 1986, a small team of firefighters found themselves battling a smoldering inferno in a highly radioactive area in the destroyed Unit 4. In their haste to locate the source of the smoke, one of them would fall through an open hatch, break his leg, and find himself trapped in total darkness, directly on the former molten remains of Chernobyl Reactor 4. Following the explosion of Chernobyl Unit 4, thousands of cables had been damaged and torn open, and as water flooded the corridors housing these severed cables, they short-circuited. The power to large portions of the building had been cut during the explosion, and when the diesel generators ran down in the morning. However, dosimetrists and scientists alike were keen to enter these damaged sections of the building to assess the damage and any potential risks. This would require restoring power to the building, so they could actually see what they were doing. Yet, there was no way to keep track of the tens of thousands of cables which had been severed during the building's partial collapse, and were now exposed, or even submerged in pools of water, ready to short-circuit and ignite at any time. Staff at the Chernobyl MPP attempted to delay this reconnection of power, explaining the risks. However, pressure from NICIAT, the VG Koplin Radium Institute, and the Government Commission, all of which had sent employees to Chernobyl to assess the damage, forced them into turning the power back on amidst the risks. All they could do was hope. All hoped that it was safe enough to restore electricity without triggering further short circuits or fires. Thus, they restored power cautiously. Cautiously in this case, meaning they stood ready to cut it again if something began smoking. After power was restored, Reconnaissance was quickly underway in the damaged portions of the building. Shortly before 2 a.m. on May 23rd, 1986, just 4 weeks after the initial explosion, head of the reactor shop Sergei Petrovich Lebedev was performing dosimetric measurements in the building. He began his measurements from corridor 406-2, which connected the north and south main circulation pump holes of Unit 4. Electrical cables for sensors and instrumentation ran along the ceilings and walls, many severed and dangling after the explosion. Sections of the plastic floor covering had been torn up, and debris from piping and walls littered the passage. Aleksandr Agilov passed through the corridor on April 26th as he was assessing the damage with Sasha Yovchenko. He remarked, "Then we approached corridor 406, which connects one MCP hall with the other. What was there? First of all, darkness. Then, some cable boxes ran through here. These cables were hanging down. The plastic floor covering was all over the place. There were some building materials. In short, it was something awful, and going there was a bit frightening. We were extremely wary. I shined the flashlight and said, 'Sasha, don't touch the cables. They could be live.'" Lebedev began his measurements from the entrance to the north main circulation pump hole, where his dosimeter read 300 Röntgens per hour. At radiation levels this high, workers in the sarcophagus would reach the administrative dose limit in mere minutes. Konstantin Checherov of the Checherov Institute of Atomic Energy, who had explored the sarcophagus hundreds of times, later recalled, "At the time, a radiation level of a few tens of Röntgens per hour was considered normal, hundreds still acceptable, and only when the smell of ozone appeared, above 1000 Röntgens, was rapid evacuation required. Measurements were still within acceptable levels. Acceptable, of course, being a flexible term in May of 1986. And so, Sergei carried on with his work. Moving swiftly, he marched south through the corridor, measuring 200 Röntgens per hour near staircase 257. The staircase led up toward previously assessed corridors, but also down into unexplored territory. One floor below was corridor 301-6 on floor +9, connecting maintenance equipment to the sub-reactor space, room 305-2. Descending another floor led to the cable corridor 217-2 on floor +6, later infamous for reasons unknown to him. As he neared the stairs, his dosimeter surged, and the device had reached its upper limit. The radiation had not. From where he stood, heat seemed to radiate upwards, as if intense radioactive decay was occurring below. No one had dared descend those stairs, because, well, why would they? The risk was far too high. It would take months before those floors below could be accessed. Continuing south along the corridor, he recorded further measurements, ranging from 100 to 200 Röntgens per hour. Beyond the stairs, the floor was scorched black, evidence of something extremely hot. The unusually high radiation, combined with the burnt flooring, indicated a source of intense heat and radioactivity directly beneath him. At the end of the long corridor, he entered the south main circulation pump hole. There, his worst fears came into fruition. Their hope had been misplaced. What he saw was thick, black smoke filling the room. Chernobyl Unit 4 was on fire. Again. He quickly radioed his superiors while hastily making his way out of the building. Within a few minutes, the local fire departments had been alerted. After being informed of the high radiation levels in the premises of the fire, 50 to 200 Röntgens per hour, they decided to alert as many fire brigades as they could. First, they alerted the fire brigades stationed in Chernobyl town. This included several firefighters from Pripyat, Kharkiv, Chernihiv, Kiev, and pilots from Zhytomyr, totaling 138 men in the main body heading north towards the nuclear power plant. Many more would voluntarily join the fight against the blaze, totaling 282 firefighters by sunrise. The man in charge, Vladimir Maximchuk, had decided to combat the blaze in a way that would limit the radiation dosage for his men. He would send in groups of just 5 men into the southern pump hole, and he instructed them to immediately leave once they had completed their task. And they would be replaced by yet another group with the same instructions. Maximchuk was the only one to remain in the pump hole for an extended period of time, only leaving when another group was to be called up. The first group of firefighters were able to quickly assess that they were dealing with a major electrical fire, and so they cut the cable to the burning areas. From outside the pump hole, they cut open a cable box and inserted a hose into the cable pipe that would lead to the burning portions of the southern pump hole, attempting to smother the blaze with water. Eventually reaching their dosimetric limit, they left, and another group went in and found another entrance to the cable shafts, inserting another hose. Eventually, using these groups of 5 men, they were able to set up a network of hoses through the cable shafts, and they began pumping water in, intending to smother the fire. By dawn, nearly 300 firefighters were on site, ready to pump water into the building at a moment's notice. Coordinating them inside a partially collapsed nuclear reactor was another matter. However, their orders stood. Get in there in small groups of no more than 5, try extinguishing the blaze, and leave after no more than 10 minutes. The first of these new volunteers went into the southern pump hall, and it took only 4 minutes for them to identify the source of the fire. They were able to look down into the cable tunnel and see a bright, glowing light, accompanied by flickers of fire and thick black smoke. Within another 4 minutes, they had extinguished that cable fire using foam. It turned out the fire was not as large as they had initially thought. The fire was ultimately traced to a cable shaft. In a building full of nuclear fuel, it was an electrical fire that proved most persistent. However, they had no time to celebrate their victory. At around 8 a.m, another cable fire had broken out, this time closer to the eastern end of the southern pump hall. One firefighter, trying to find the source of the blaze, thought he found a lead. A large, square hatch on the floor seemed to be radiating an intense heat. He opened it, and nothing, no smoke, no fire, just heat and darkness below. He left it open, and then helped his comrades to battle the blaze in 402-3. Yet again, they were able to quickly extinguish this blaze by directing a jet of water into the cable tunnel. Before they left, they decided to quickly check the area for any smouldering blazes that could ignite again. As they split up, one firefighter scanned the corridor 406-2 toward the north pump hole. Smoke still lingered in the air, cables still dangling from the ceiling. He was unable to see any sources of fire and smoke, but he had to be sure, so he kept looking. His vision narrowed, focused on the far end of the corridor. Then, in an instant, the floor disappeared beneath him. He fell nearly 2 meters into the corridor below. He landed on a piece of maintenance equipment suspended from the overhead railing. The hatch above had been designed to allow this equipment to pass through, and for some reason had been opened. It broke part of his fall, but he still hit the floor hard. His legs absorbed the impact awkwardly, and he felt a sharp snap. His leg had broken on landing. All he knew was that he had fallen into a dark corridor, so dark he couldn't see the floor beneath him. And it was hot. Incredibly hot. The kind of heat that pressed against his skin and melted his boots to the metal equipment under him. The air smelt of burning dust, and more worryingly, ozone. However, for him, that was the least of his concerns. He couldn't move without a sharp, unbearable pain shooting through his leg, and he couldn't climb out himself. So, he called his comrades for help. Just as the other firefighters were about to leave, they heard a shout from one of the hatches. They ran over and found the source. The open 2x2 meter hatch, just beyond the end of corridor 406-2. Inside, they found the unlucky firefighter, but also immense heat, radiating upwards from the hatch, as well as a faint metallic taste in their mouth. It was all too familiar. Quickly, they were able to find a wooden board, where in less than 2 minutes, they were able to tie a rope to it, and then lower it down to the unfortunate firefighter. He grabbed on, and it took 3 firefighters to pull him out, where he was quickly rushed away to a hospital. We will talk about what happened to this firefighter later. As more firefighter teams were rotated in and out, the fire continued, and another cable shaft had ignited in room 403, north of the pump hall. Unable to successfully extinguish the blaze using water, they chose to use foam instead. This changing plans had occurred far too late, as their water had already flooded the transport corridors below. Before they could proceed in using foam, they had to seal the drains that would take water away from the cables to the transport corridor. So they did. A few shifts, 30 minutes, and the job was done. Finally, they could fill all the cable shafts with foam. For the moment, the fires were extinguished. Over the coming hours, some smaller blazes would ignite in the building. However, Nikolai Steinberg simply decided to let the fires burn themselves out, rather than risking the health of even more firefighters. His plan worked, and no more blazes would ignite following May 23rd. The firefighters who rescued the firefighter from the hatch reported to their superiors their accumulated dose that their dosimeters had read. The number was so high that their superior didn't believe them, and they were denied leave from the exclusion zone. The fates of these firefighters were not documented. In the bunker, the government commission had to deal with the fact that their impatience had led to a needless fire that had irradiated countless firefighters and given one life-threatening injuries. They chose to halt their plans and disconnect Unit 4 from the electrical grid. And so, by May 26th, Unit 4 was once again separated from the rest of the building. Within the weeks following the blaze, the government commission found themselves between a rock and a hard place. They urgently needed to explore the building, assess the damage, locate the fuel, and determine how much of it had truly escaped the building into the atmosphere. Aleksandr Borovoy, a scientist in the government commission who would eventually become a key figure in sarcophagus research, was the first to try and tackle this issue. He developed a mathematical model to determine the activity of radionuclides and their spread in the building, to try and determine how much fuel remained inside. This was followed up by a more advanced model developed by Valery Legasov, which came to the conclusion that 90% of the nuclear fuel remained inside the building. The next step was finding the missing fuel. Enter Konstantin Checherov, and several employees from the Checherov Institute of Atomic Energy. In May, he had written several requests to Legasov to be sent to Chernobyl. Only after his fourth written request, Checherov was finally approved to fly to Chernobyl. Bureaucracy, as always, moved at its own pace. Arriving on June 6th, he and his team of dosimetrists were assigned to work under Vyacheslav Dmitrievich Besmeny. Over the next few days, Checherov conducted several flights over Unit 4 with a temperature sensor. The readings he got simply didn't make sense. Inside the core was a mere 24 degrees. He couldn't find 100 degrees, let alone 1000. A few days later, he was able to measure 54 degrees and a mere 150 rontgens per hour emitting from the core. Yevgeny Velihov remained indignant, convinced the instruments were broken, or possibly lying. This can't be true. What did you measure? It's the reactor shaft. There's melted fuel there, and the numbers should be higher. Checherov knew what those readings had to mean. The core was empty and devoid of fuel. It must have all escaped the core and spread out through the building, like lava. He just had to prove it. As of yet, none of this supposed fuel lava had been located, and as he was the one suggesting such a ludicrous idea, it was now his responsibility to find it. By June 9th, he, along with several Checherov employees, were going back into the sarcophagus, this time in the dark, to locate the fuel. First, they assessed all the safe areas. Everything above the sub-reactor space, starting from plus 12.5. They began their assessment. One of these employees was dosimetrist Mikhail Sergeyevich Kostyakov, one of the more senior colleagues, and a veteran whom fought the Japanese in World War II. He was an expert in his instrumentation. He redesigned his DP5V dosimeter, making it several times faster, although with a higher margin of error. But they didn't need precision. The main thing was to assess radioactivity levels, and do it quickly, to minimize their own dose. On the 10th of June, Checherov, Kostyakov, and another dosimetrist, Vladimir Ivanovich Kabanov, were working in the south main circulation pump hole, taking measurements and assessing damage from the previous fire. The room was covered in a layer of soot, and there was no light except for the shining coming from the headlamp of their miners' helmets. Entering from the western side, they measured up to 200 Rontgens per hour, reaching the middle of the pump hole. Kostyakov chose to continue on along while Checherov and Kabanov took more detailed measurements in the pump hole. Kostyakov made his way towards the eastern end of the pump hole, and was about to enter the long corridor 406-2 when he found the open hatch in the floor that he was looking for, about 2 meters in diameter. It was difficult to see in the darkness, so he walked carefully, and as he approached the hatch, his dosimeter surged and went off the scale, above 1,000 Rontgens per hour. He stepped away from the hatch and continued his survey. He entered corridor 406-2 and followed it to the northern main circulation pump hole. He measured the radiation at the northern pump hole's entrance, where it was around 200 to 300 Rontgens per hour, and turned back. He passed the hatch more quickly, knowing the levels there. That evening, Kostyakov returned home for his evening meal with his colleagues, and he scratched the side of his leg. The skin was peeling. He had sustained a beta burn from walking near the hatch for only a few seconds. This meant extreme radiation levels, which had to be investigated further. Maybe they had found the fuel, so he reported his findings to Checherov. On the 11th of June, Checherov returned to the pump hole, this time alone, to try and measure the dose within the hatch. Armed with the best dosimeter he could find, rated for 9,000 Rontgens, it was, at the time, considered more than sufficient. He began to approach the hatch, when even that went off the scale. In the vicinity of the hatch, there was a minimum radiation level of 9,000 Rontgens per hour. The instrument had reached its upper limit. He had still come prepared. He strung together 6 500 rad accumulators spaced half a meter apart, then ran to the opening, lowered the string, and quickly moved to an area with the lowest background radiation he could find. 15 minutes later he returned, pulled out the string of accumulators, and did the maths using the readings they had measured. He determined that at the floor level of the pump hole inside the hatch, the dose rate was 10,000 Rontgens per hour, and inside the hatch, a meter above the floor, it was 11,400 Rontgens per hour, over 3 Rontgens per second, enough to deliver a lethal dose to half of the people exposed in under 3 minutes. Radiation levels this high had not yet been encountered inside the building, and Checherov believed he may have found the fuel. However, he could not investigate further, as even being near the hatch posed a risk to his life. Little did Checherov know, he was entirely right in his assumption. Checherov investigated more remotely. He consulted the floor plans and identified the hatch. It was located near the eastern end of the southern pump hole on level plus 12.5, and descended 1 floor to corridor 301-6 on level plus 9, the same level as the sub-reactor space beneath the reactor. Could it be that fuel had travelled out from the reactor into the sub-reactor space, then to 301-6 and down to where the hatch was? There was an obvious path for the fuel to take, but there was only one issue. The hatch was over 20 meters from the sub-reactor space. Surely not, he thought. There was no way fuel could have travelled that far from the core. However, there was only one way for him to find out. Over the coming weeks, Checherov, Kostyakov, and Kabanov attempted to find a safe access route to that corridor. However, they could find no clear route. Attempts from plus 12.5 via staircase 257 proved to be far too radioactive, and the same went for staircase 256. The only other option they had was to try to find an access route from beneath. However, they didn't have much time. Soon, all expedition work was to be halted to allow for the construction of the sarcophagus, and the pouring of concrete into the structure. So, later that month, Kostyakov and Kabanov set off, from the clean staircase on the ground floor. They made their way through the corridor 025-3 toward 017-2. And when they entered the corridor, they found the ascending staircase to their left that they were looking for, that would take them to 217-2 on plus 6, where they could try getting to plus 9 from the floor below. However, when they raised the dosimeter up the stairs, the readings began sharply increasing, and when it reached the threshold at the top of the stairs, it went off the scale, 3,000 rontgens per hour, and broke. They decided to just leave the dosimeter there and turn back, declaring yet another attempt unsuccessful. Kostyakov and Kabanov did not know yet, but at the top of the stairs sat the elephant's foot. Checherov, now with all possible routes to access being far too radioactive to traverse, gave up, and as the construction of the sarcophagus began, it wouldn't be until December that he could try again. However, by that time, he had lost interest in sending Kostyakov and Kabanov to find yet another impassable route. By mid-December 1986, Vasya Koryagin, a speleologist at the Checherov Institute, had devised a plan to access the sub-reactor space 305-2. Koryagin had a particular obsession with the bottom of the reactor, like an itch he needed to scratch, and so, without any help from Checherov or his superiors, he set off alone. Koryagin's devised route involved descending the staircase 257, down to plus 9, and taking a left into 301-6, and then his first right into 318-2, and from there the first door on his left would lead to 305-2. As fate would have it, Koryagin somehow missed the floor he was supposed to exit staircase 257 at, and ended up leaving the staircase on plus 6, the corridor into 217-2, where he came face to face with the elephant's foot, and became the first person to truly discover it. After Koryagin's discovery, Checherov was finally informed, and so he went to the foot himself to see what it was. He found the object to have a black, glassy appearance, like lead, and this is what he initially believed it to be. However, Checherov was skeptical, and believed it could have been nuclear fuel, and so he ordered for samples to be taken, something that would take several more months. Checherov's skepticism stemmed from the fact that research by the Government Commission had shown that nearly none of the lead dropped by helicopters could have made it into the core, let alone this much, paired with the extremely high gamma radioactivity of 8,000 rontgens per hour that he had found. Checherov reminisced about his discovery of radiation in the hatch, and what it could mean when linked to this new discovery. Consulting the floor plans once again, he found that where the hatch led into, 301-6, was directly above where they had found the elephant's foot in 217-2. Could it be that the radiation he found in the hatch was in fact from nuclear fuel, like he had initially believed? Had a firefighter in May fallen into a corridor filled with once molten nuclear fuel. He couldn't be so sure, and he didn't have any concrete proof at the moment. By the spring of 1987, the analysis of samples taken from the elephant's foot proved Checherov's theories. The lava contained not lead, not boron, not dolomite, but zirconium, sand, serpentine, other parts of the core, and, most importantly, nuclear fuel, originating from Chernobyl Reactor 4's fuel rods. They had found what they were looking for. There was only one question. Where was the rest of it? Aleksandr Kupnyi, head of the complex expedition, was assigned the task of locating the remaining fuel. By the end of 1987, additional accumulations of fuel were discovered, sometimes only after cutting new openings or demolishing interior walls. Yet a significant portion was still unaccounted for. The evidence increasingly pointed towards level +9, the level directly beneath the reactor, the same level into which the hatch descended. Unfortunately, much of that floor had been entombed in concrete during the construction of the sarcophagus, making direct access nearly impossible. Kupnyi proposed drilling boreholes into the sealed sections of +9 to locate the missing fuel. The plan was approved under Boris Shabina, and a reorganized expedition under the Checherov Institute began preparations. By the spring of 1988, many boreholes were operational. What they revealed would finally clarify what happened on +9. The nuclear fuel had escaped from the reactor into 305-2, from which some fuel descended vertically into the steam distribution corridors. The rest of it escaped horizontally, melting through the wall into 304-3, where it then spilled out into 301-5, and then east to 301-6. From there it flowed out and filled the southern end of the corridor with a layer of corium up to 30 centimeters thick, spreading all the way to below the hatch. From there, it descended through cable holes further, into the corridor 217-2, where it formed the elephant's foot and several stalactites. Checherov now had the full picture. The hatch, which was a seemingly unremarkable feature of the southern pump hole, was in fact positioned directly above one of the most intense accumulations of nuclear fuel in the entire building. The radiation he had measured months earlier, which had sparked both curiosity and concern, was no longer a mystery to him. It was the innards of reactor number 4. We can confidently say that, on May 23rd, 1986, a firefighter literally fell onto Chernobyl's Reactor 4. Now we need to talk about the elephant in the room. What happened to the firefighter? Well, we aren't quite sure. In an article published by Aleksandr Kupnyi, containing a memoir from Konstantin Checherov, Checherov states that the firefighter later died of radiation sickness. This is vague, but it makes sense. The firefighter fell into a zone that would provide a lethal dose in literally 2.5 minutes. In the amount of time it could have taken to rescue him, he very likely could have received a lethal dose. There is only one problem with this: the lack of documentation. According to David01, who runs the Chernobyl Revisited YouTube channel, and has access to many of the hospital records, no firefighter was admitted to Moscow Hospital 6 with a high dose, let alone died, in late May to July 1986. Supposedly, people were being admitted with doses as low as just 10 rem, which this firefighter would have received in only 5 seconds of being in the hatch. But there's a counterpoint to this argument. the hospital records sometimes left people out, and perhaps the hospital records were originally shared incomplete, and therefore lack the concrete certainty we need for this debate. Furthermore, the firefighter could have been transported to other hospitals. It is known that hospitals in Kiev were accepting patients from Chernobyl. Among them was Alexander Lenachenko, an electrician who remained on site from April 26th until early May, and was one of the first victims to succumb to radiation poisoning. So, what happened to the firefighter? We may never know.